I sort of hinted that waves are what? What are they? What do they do? I can't hear you. So you can have energy going in or out of a system through work or EDIS, right? But now we're saying, look, EDIS is really a lot of different things. One of those things is waves. So energy can go, for example, from the sun to earth, and the wave energy is just transportation of energy, not stuff. Matter isn't going from the sun to earth. It's actually just energy. In the ocean, there's a storm far away, and that energy can get to the beaches here. Does that make sense? It's not like the water changes composition from those waves. The waves don't bring special water from there to here. But energy is transported. Does this kind of make sense? So the question is, how do you find the speed of a wave? So you have this beginning worksheet where we talked about wavelength and period. How could you use this to find wavelength? Help me out. So I need someone to help me figure out how to find wavelength. Length of a wave. Which graph would I need? Length of wave is what we want. It's called wavelength for sure. Go ahead. What's a wavelength? What's a length of one wave? No fancy equations, in your own words, please. Which graph first? Which graph? This graph or that graph? The top one or the bottom one? They're the same. Okay. If you think they're the same, look carefully. Right here, right here. So, which one of these will give us a wave period? Which one of these will give us a wavelength? So if you use this graph, you're essentially measuring the length in what units? Yeah. So you use a meter stick and you measure from where to where? Where's there? Okay, I'll start here. Tell me when I'm at one wavelength.
Stop.
Here? 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 Here. Okay, yell when I stop at one wavelength, please. Good. There's a possibility. This would be one wavelength. The symbol is kind of cool. It's a lambda. All right? Another way you could measure it is from here to there. That would be one wavelength as well. Another third way I could do it, I could start here and I could end there. Do you folks see how these distances are all the same number? Is everybody cool? Now that you know what a length of wave is, otherwise known as wavelength, what's a period? What's a wave period? Period is short for time period. From where to where? I'll start here. Tell me when one period is. No. That's half a period. So, you see how fundamentally we're measuring the same characteristic of a wave with either a stopwatch or a meter stick. Are you guys good? Fundamentally, aren't we measuring the same property of a wave? We're either using a meter stick and calling it wavelength, or we're using a stopwatch and calling it wave period. Make sense? And the symbol for period is a capital T. All right? And I could start here. Where would I have to end? Oh, you guys missed it. Try it again. If I start here, what would one period be? Now you're doing it. Good. All right. And another way I could do it is I could start here and stop where? All right, is everybody cool now? So those are the basic properties. There's a little bit more here. First, using wavelength and using period. Tell me how you could find the speed of a wave. This works for any wave. The units here are what? Okay. The units here are what? Good. So, the fundamental equation for wave speed is it's like way too loud. Fundamental equation for wave speed is what? So it's lambda means wavelength. Good. You're right. Over. What's that stand for? Okay, and we call it the period. All this means is we're talking about the time for one wave and the length of one wave. That's all that means. Because waves repeat over and over, we just got to measure one of them. Cool? You guys good? Okay, there's one more thing that's a little tricky. So this is your fundamental equation. Okay? There's also another property we talk about. Instead of looking at the time for one wave, okay? You said period, which is given the symbol capital T, is the time for one wave to pass, right? Not two waves, one wave. Everybody good? Everybody good here? Okay? There's another way we could look at it. May I write this as a fraction? I think it'll be easier. Okay? So time per wave, right? Can I flip it over? Then what do I have? I have the waves per time. Make sense? Okay? What do you think the symbol of this is? What do you think it's called? How many waves pass per second? It's measured in hertz. Those are the units. Maybe I'll write the units over here. Keep them separate from my equation. Units for period are what? I'm not asking this one, I'm asking the top one. What are the units for period, please? The units? Seconds. Okay? So I'll just make up a number. Let's say the period is 10 seconds. Is everybody good? All right. How many waves would be passing per second if I had a period of 10 seconds? I'll try it again. How many? This is hard. You have to think about it, but it's easy once you get it. If you know it takes 10 seconds for one wave to pass, how many waves pass per second? I need to say it again, I can tell. Don't answer it, let people think. Okay? No, you're doing good, just wait. Patient. So I ask again. Please think about it. It'll make a difference. You'll get it if you think about it. Okay? If it takes 10 seconds per one wave, my question is, how many waves would be crossing in 1 second? You're getting it. This would be 1/10 of a wave passing, otherwise known as 0.1. And this is called 0.1 hertz. A hertz is just an inverse second. Okay? And the name given to this symbol is F for frequency, and it's called frequency. Okay? Last thing you need to know how to do. Okay? Another equation for wave speed isn't based on wavelength and period. It's based on wavelength and frequency. What do you got to do with wavelength and frequency to get the wave speed? Use the units to figure it out. If you know the frequency and you know the length of a wave, how can you find the wave speed then? Yeah. Let's say you don't know the period, but you know the wavelength and you know the frequency. How can you find the wave speed then? Okay, I said use the units. The units of frequency are what? Hertz, 1/2 Is everybody good? 1/2 is frequency already. Wavelength is meters. How are you going to get meters per second with wavelength and frequency? What do you got to do? Frequency is 1/2. Wavelength is meters. Multiply what? Multiply what?
Meters.
What variable? You're right with the units.
Lambda.
Lambda?
Lambda.
Okay, so it's called wavelength times. Okay, please don't miss the unit. Please don't mix up the units and variables. You're right. The units of frequency are hertz. So you're taking 1/2 and you're multiplying by meters, which is wavelength, and that should get you meters per second, which is our wave speed. You guys good? Are you guys cool? I'm trying to think if there's anything else you really got to know here. Yeah, go.
How do you find frequency?
How do you find frequency if you only have wavelength? Do you know the speed of the wave? See, you would need to know the speed of the wave. Go ahead and read the question, please. Okay, wait. X-rays. Are those electromagnetic? How fast do electromagnetic waves travel? What's the speed of light? What number? Good. So good math. So Victor, read the question one more time. Appreciate if you're quiet. You have to read it really loud for people to hear you.
An X-ray has a wavelength of 4 times 10 to the negative 11 meters.
Okay. So you know the wavelength is 4 times 10 to the what?
Negative 11.
-11 meters. What else do you know? C, which is the speed of light, right? Which is, Jose said, was 3 times 10 to the 8 meters per second. Yeah, that's a great number to know. What are you looking for? Okay. Tell me what fundamental relationship you can use. This should be an easy problem for an honors course. Would you use this one? Would you use that? Aaron, you've been talking pretty much the whole time about random stuff. You're not the only one. That's rude. Go ahead. You gonna use this one or this one down here? They're the same thing. So you can, for sure, you can just write wave speed equals wavelength times frequency. What are you solving for here? And it should be, again, very easy. These problems with waves are very simple. It's just understanding what we're measuring, understanding the basic properties of a wave, and realizing that all waves behave the same way, which is pretty cool. I can use the same equation for ocean waves, and I actually use this one a lot, where you got speed is wavelength over period. I know these two things, And I can calculate how fast a wave is going in the ocean after the wave is created by a storm. And I can figure out exactly what day down to the hour that it's going to get to a beach I like. Does that make sense? It's like 2 weeks. From a storm off of Australia, it's about 2 weeks to get here. It goes about 30 miles per hour through the ocean. And the cool thing about it is it going to be any different than the battery-powered vehicle? Once that wave is set in motion, is the speed going to change? That's what's kind of interesting about waves is once they're done, once the disturbance has created the wave, it travels with the same constant speed throughout the whole ocean until it gets here. Kind of sweet. So it's just like your battery-powered vehicle lab, the symbols have just changed. So that makes it pretty simple. You already know the physics of it. You guys good? Question?
Isn't there gravity?
Speak up.
Isn't there gravity involved with ocean waves?
Yeah. You don't have to know this for the class, but I like to try to make sense of stuff. And if you reflect on the whole year, right? When you have a force on a particle that's unbalanced, what does it do? What kind of motion do we get? When you have an unbalanced force on a particle. Please stay with me here. I'll try that again. You should all know this. When you have a constant force that doesn't add, forces don't add to zero acting on an object. You have acceleration. When you have the forces adding to zero, you have constant velocity. Okay. What would happen if you had a different, still an unbalanced force, but it's a restoring force? Because, like, if I pull a spring, right, the spring wants to go back to its initial position, right? What if I compress the spring? Doesn't it want to go the other way? You guys with me? If I compress a spring, it wants to go back to its equilibrium. If I stretch a spring, it wants to go back to its equilibrium. Well, what would happen if you hung a mass on a spring and pulled it? Wouldn't it bounce up and down? Okay. Well, that's called an oscillation, right? An oscillatory motion is caused from an unbalanced restoring force. And an oscillatory motion is the kind of disturbance you need to create a wave. In the ocean, you need the wind to blow and stop, and blow and stop with a very specific frequency. That frequency ends up transferring energy to the ocean. Does that make any sense? So you need that. A storm doesn't just blow strong wind and the waves are created. You need strong wind blowing with a specific frequency to make a good ocean swell. I should be quiet. Are you guys good? Last call for questions before I stop. How much time? Okay, use your time wisely. Ask me any questions.